Hi, I'm Lisa, and this is Threshold in China. Today we are going to share some exciting tech, innovations, and announcements that happened in China recently. China has built the world's most powerful thermal-acoustic power generator. Well, what is it exactly? Generally speaking, it is a generator powered by heat and can deliver energy in silent, so it is widely used in industries such as submarines and aerospace, basically when you don't want to be detected. It was created by researchers at the Technical Institute of Physics and Chemistry (TIPC) of the Chinese Academy of Science. In recent tests, their system delivered 102 kilowatts of electricity from a 530 degrees Celsius heat source, and this is the highest power achieved by a three-piston thermal-acoustic Stirling generator. Its 100+ kilowatts capacity significantly expands potential application from distributed power generation to aerospace. The military, in particular, value this quiet and efficient technology. Now, Sweden has successfully used this technology in its submarines. Meanwhile, China has also been working on developing Stirling engines for naval applications. Many modern submarines that use air-independent force rely on Stirling engines to provide onboard power. Luo Ertang of TIPC noted it can utilize various heat sources using solar, waste heat, and biomass. Its flexibility and sustainability make it ideal for remote or portable use. Like the classic Stirling engine invented back in 1816, it's also a closed system that uses heat to generate power. But unlike traditional Stirling engines, it operates silently by relying on sound waves rather than steam or moving parts. The breakthrough is at its core the thermal-acoustic engine. This engine takes the heat and turns it into powerful sound waves using temperature differences. It exposes a gas like helium to uneven temperatures that cause the gas molecules to speed up and slow down repeatedly inside the engine. This oscillating motion of the gas is what generates the intense resonant sound waves that power the generator. The intense sound wave then causes the unattached piston, hence the free piston, inside to move back and forth in a straight line motion. The attached magnet then generates electricity as they shuttle through surrounding coils in the linear alternator. Comparing to traditional Stirling engines and steam plants, the acoustic approach concentrates thermal energy into organized sound waves that can effectively drive the piston. The sound propagation transmits the energy. According to Hu Jianying of TIPC, the current thermoelectric conversion efficiency is about 28%. If the heat source reaches 600 degrees Celsius, efficiency could increase to 34%. Thanks to the innovations in heat transfer, gas sealing, and vibration control, the linear alternator was able to eliminate harmful vibrations while maintaining the vital airtight seal. Because the architecture is very simple, such that there is little moving component, the generator then can operate silently and reliably. While NASA patented a similar system, China has now gone further in translating this technology from concept to reality. At the same time, China has tested another three-piston Stirling engine in space and trying to see if it can be a power source for space stations. However, the way the technology works is a little bit different to what we just described. The full name of this technology is called a three-piston Stirling thermoelectric converter. It directly converts heat energy into electricity by utilizing the thermoelectric effect. During the test, the thermoelectric converter performed in a stable manner throughout the entire process and produced better than expected performance indicators. The potential of this technology lies in its ability to reduce a spacecraft's reliance on solar energy and offers an additional power for upcoming crewed missions and explorations in deep space environments. Previously, we introduced an AI robotic chemist called Xiaolai that can autonomously design, execute, and analyze experiments. It now has a new job to produce oxygen from Martian meteorites. As humans, we dream about moving to other planets like Mars. The first step to take is to overcome the lack of oxygen in the Martian atmosphere. Recently, the team from the University of Science and Technology of China, in collaboration with the National Space Science Center of the Chinese Academy of Science, used Xiaolai to prepare particle oxygen evolution catalysts from Martian meteorites, and they succeeded in producing oxygen. This remarkable achievement can potentially reduce the cost and complexity of human missions, while enabling sustainable explorations by utilizing local Martian resources. While the oxygen required for human activities cannot be replenished in the Martian atmosphere, recent evidence of water activity on the planet has raised hopes for large-scale oxygen production through electrochemical water oxidation processes. This process relies on an oxygen evolution reaction (OER) catalyst to lower the energy barrier to make water splitting more efficient. Theoretically, solar electrolysis with an effective catalyst could yield fuel and oxygen using local resources. Can this be achieved on Mars? AI seems to provide the perfect solution. Xiaolai analyzed the mineral composition of Martian meteorites using onboard laser-induced breakdown spectroscopy. It combines machine learning models with theoretical simulations and experimental data to automatically and rapidly identify the optimal catalyst formula. The entire process is carried out by AI, from the pre-treatment of the Martian ore to the synthesis, characterization, and testing of the catalyst. It then ran 203 experiments on its own over a 6-week period. The optimal catalyst formula was identified from over 3 million possibilities. It could take over 200 years if human chemists relied on trial and error. Producing oxygen from native Martian materials represents a pivotal step towards building habitable areas on Mars. In this study, the team stimulated Martian conditions to the maximum. With Martian catalysts covering the roof of a 300 cubic meter module, after 15 hours of solar power electrolysis, the oxygen levels are sufficient for human survival. It seems that this breakthrough AI technology is bringing us closer to sustainable explorations and settlement on the red planet. And that is all for today's Threshold. We hope you like this new section on science and technology in China. As usual, we welcome your feedback and thoughts.